Welcome guys. I address my cordial greetings to you all. This video is actually based on solutions to Mat102 test question. Now, for the first question, we need to consider question number 1, which says a curve has equation y equals to x cubed plus 3x squared minus 9x plus p, where p is a constant. This p here is actually a constant. Hence, the question says we should find the value of p. This is very, very direct. The first thing we need to do is we all believe that a stationary point, it is believed that the derivative of y with respect to x is always equals to 0 at stationary point. Now, let's get the stationary point for x. Now, in this case, since y is equals to this expression we actually have here, now if I differentiate whatever I have there, which implies differentiate, that is d dx of x cubed plus 3x squared minus 9x plus p equal to 0. That is, this is the y, this is the expression for y given with respect to x. Now, if I differentiate x cubed with respect to x, we all believe that that should give us 3x squared. You are familiar with that. And at the same time, if I differentiate 3x squared, I'll surely have 6x. Minus, if I differentiate 9x, I have 9. If I differentiate this constant, you all believe that we have 0 in that case. Then equals to what? 0. Now, if I decide to solve for x, in this case, you just have to use the idea of factorization. So by the time we make use of plus 9x, this is the best substitution to use in this case. I believe you all know how to do that. And then from these two terms, it is believed that 3x is common, and I'll be left with x plus 3. And at the same time, minus 3 is common to these two terms. If minus 3x divide this, I have x left. Minus 9 divided by minus 3, I have plus 3. So finally, we have 3x minus 3 is equals to 0, or x plus 3 equals to 0. By the time you take this to the other side and then you divide both sides by 3, you have x is equals to 1. The same thing applicable in this case. You have x equals to what? Minus 3. Now, the problem is we want to find the value of p for which the curve has a stationary point on the x-axis. And looking at this, I have the x value to be 1 and x value to be minus 3. So if I want to find the value of p, it is very, very direct. Just come straight back to this y equals to x cubed plus 3x squared minus 9x. When you recall from here, then you have y is equals to, now we have two values for x. When x is 1, substitute your 1 here, you have 1 raised to the power of 3, then plus, you have 3 times 1 squared in this case, then minus 9 times 1, then plus p. That's for the first stationary point for x. And at the same time, for the second one, we also have x equals to minus 3. And then by the time you substitute into this case, you have minus 3 raised to the power of 3 plus 3 of minus 3 squared, then minus 9 times minus 3 plus p. So if I decide to simplify this further, this is what we are going to have. Now you have y equals to, then you have 1 plus 3 minus 9 plus p. Similarly, in this case, we have minus 27. Minus 3 squared is 9 plus 27. Minus minus, that's plus 27 in this case, then plus p. This cancel this. This is 4 minus 9, and I have minus 5. So I have y equals to minus 5 plus p. And at the same time, I have y equals to 27 plus p. So if I substitute y equals to minus 5 plus p in this case to get the value of my p, so this is what we're going to have in that case. When this y, substitute the value of y, okay, sorry for that. Now if I return back this, I have minus 5 plus p is equals to 27 plus p in this case. Then if this comes like this, I have, okay,